What is it doing? This is too important. I don't want that to stop. Okay. So if you don't want to write it like that, write it in words, but some mathematical symbols like the distance and everything, they still have to be in the absolute value form. There is no other way. So for every epsilon positive, I will find the corresponding delta positive. Delta will always depend on epsilon. Delta will always depend on epsilon. Such that whenever I pick, can anyone tell us what to write now?
3 over 2x minus 1/2.
We're talking about delta. I cannot jump to the function before I write the delta part.
Is it x minus 5?
That's it. Very good. This will imply because here I pick x close to 5.
Now you put the function into this.
Very good. Good. And then
-7.
that's it. Awesome. This is our starting point, number 1. I start here. 3/2 x minus 1/2 minus 7 less than epsilon. What would you do inside? After the second problem, you'll say, oh, it's so easy. It looks difficult, but it's very easy. So what do we do inside the absolute value?
Combine like terms.
Good.
So the -1/2 minus 7.
The least common denominator.
2.
Good. So what do we have to write at the top?
3x minus 2. No, wait. 3x minus 2 minus 14.
-1 minus 14.
I agree. Because they have the same denominator. This doesn't need anything. This doesn't need anything. Only this one needs it too. Awesome. Everyone okay? Agreed? Okay, the next step, please. What do I write next?
Would you separate them so that it's an absolute value on the top numerator and then over the absolute value of the denominator?
Yes, but I have one more step. Yes, that will be the next one. But I have one more step. But you're right. You can do both. I would agree if you want to do both steps in one. I will agree with that part. But what do I have at the top first?
A -1 minus 14.
So it'd be 3x minus 15.
Good. In absolute value divided by the absolute value of 2. So you can do that in one step. Combine like terms here and also use the property. I'm fine with that. Good. What can we do at the top other than that? So I'm cheating a little bit. This is what I want. I want this. I want to get to this. This is my starting point. Yes. In absolute value, though. And I can change this into 2. Next step.
Absolute value of 3.
Yes. Yes. So allow me to continue on this side. So the absolute value of 3, the absolute value of x minus 5 divided by 2 less than epsilon. Perfect. Now I change the absolute value of 3, right, into 3. I can do that now. Remember what I'm after. What should I do to both sides?
Multiply by 2/3.
Excellent, well done. X minus 5 less than 2, 2 epsilon over 3. How much is delta?
2 epsilon over 3.
That's it, done. And of course, step 2, show that delta works. And you know the sentence that you have to put in there. So now if you say epsilon is 0.1, then delta will be 2 times 0.1 over 3. If you say epsilon is 1, then delta will be 2/3. And I can go on forever. Why? Because the limit exists. For any epsilon, I will find a delta, depending on epsilon, of course.
Okay, I lost it in the middle of trying to copy stuff down. We did the x minus 5 is less than 2, so we're just saying the delta is x minus 5. That's all we're saying, correct?
No.
So the absolute value of x minus 5, I was trying to figure out how we went from the last step to the one or from the previous to the last step.
By comparison. We compare this to this.
Okay.
Delta has nothing to do with x minus 5.
Okay.
So this is what I want. I start here, and I want to get here. As long as I have x minus 5 in absolute value on this side, on one side, the other side must be delta. Is that better? Anyone?
I'll rewatch the video to make sure.
Good, but is this okay?
No, I'm not following that either. I don't know how we get. I don't. So we have absolute value x minus 5,
Yes?
and then is less than
Yes?
delta. I don't know how we get to that final part.
You mean from here, here?
Yeah. I don't know how we're getting x minus 5 on the other side of delta.
But you understand the step from here, here, and the step from here, here.
No, I don't understand that where you're pointing right now to the step above. I don't know how we're getting there.
So how will you solve this inequality for this quantity? So this is a quantity that you want to solve for. How will you solve this inequality for this piece?
I don't know.
You will multiply by 2/3. 2 over 3 times 3 over 2 is 1 on this side. And 2 over 3 times epsilon is 2 epsilon over 3 on this side.
Oh, that's a 2. Okay.
I have 2/3.
Okay. I thought that was a delta sign. I got it.
This one?
Yeah.
Sorry.
I'm on my phone. I'm on my phone today, so I can
So
only see so much.
it's true. I'm sorry. It's my handwriting, I guess.
Okay. Thank you.
Is this better now?
Ali, I have one question.
Yes.
You said that the delta has nothing to do with x minus 5,
No.
right?
No. X minus 5 is the distance between x and 5. Delta is that it has to be, so x has to be picked in such a way that the distance between x minus 5 is less than delta. But delta does not depend on x minus 5. Is that better? Maybe you want to rephrase your question, Sean? Maybe I didn't understand the question.
No, I actually get where you're coming from. It wouldn't matter what that variable is.
Right, so this is only saying that this piece is delta. This is not, delta does not replace this part. By comparison of these two, it only says, this says that this piece is delta.
And make sure I understand this right.
Yes.
We're just saying that x minus 5 is less than delta.
Exactly, that's what I want.
Right. It didn't come across clear. You said you were cheating earlier, so I didn't understand the cheating. Okay.
The cheating
Now I
part,
understand
the cheating part is, so to speak, cheating is that I'm looking here to see what I need to get on the left-hand side. So then I have to completely clean it up. So this is not cleaned up, this is not cleaned up, this is not cleaned up. Now it's completely cleaned up because that's what I want. I want the absolute value of x minus 5 on this side. So that everything else I have on the other is just delta. But if I have a 3 in here, I can work with that. I don't have the absolute value of x minus 5. I have 3 times the absolute value of x minus 5, so I have to clean it up. Get rid of that 3 in front.
It makes sense now. I didn't understand the cheating earlier. Now I do.
Right, so we start here, and I have to get this. Once I get this, then I know that this piece is delta. So I have to rearrange, apply all properties possible, simplify as much as possible this piece to turn into that. And once I turn this piece into that, then I know that what is on this side of the inequality must be delta. Is that better?
I'm better, thank you.
Anyone else? Questions? Okay, so let's continue now with 2.5. That's my page 4. And that is continuity, 2.5. Continuity. So what is left from this chapter is 2.6, 2.7, and 2.8, assuming we are able to finish 2.5 today. We have an hour to talk about continuity. We'll see. I know we discussed this about 9:20. This is not when the homework is due. The homework is due before class, as we discuss in class. This is just a tentative date for the test, and I'm pretty sure we have to change that. Okay, so let's take a look at what continuity means. First of all, I start graphing a function at this point. I do not raise my marker off the paper. This is a smooth, continuous function. Okay, discontinuity. In how many ways a function is not continuous? Discontinuities. So there are a few options. Here is one. It's called jump. This is a jump discontinuity. Here is another. Infinite discontinuity. Jump discontinuity, infinite discontinuity, and here's another. This is one option, and here's another possibility for the same one. The last two are identical. They are called removable discontinuity. Removable. Here it's very clear, the limit from the left and the limit from the right, etc., etc. Here the limit from the left, the limit from the right, they're infinity. There is not even, the function is not, doesn't even exist there. And I want to talk about removable discontinuity first. As you see, if this is A, as x approaches A from either side, function values approach the same value. So the limit exists here. So the limit as x approaches a from either side from f of x, of course this is f of x, is L. This is a removable discontinuity. The limit from the left equals the limit from the right, but not the function value at that point. This one is also removable. The same thing here is also removable. The same limit from f of x as x approaches a from either side is L. This is also removable. What's the difference? Here the function is not defined at a, but here is. It is defined at a. So what does continuity really mean? Continuity at a point. So here's a function. Is it continuous at p? Yes. Why? Continuous at p because the limit as x approaches a, of course this is a and this is L, from the left of f of x equals the limit of f of x as x approaches a from the right and equals the function value at that point. So this is a very important definition. You will be tested on this definition and also removable discontinuity. So continuity at a point means the limit has to exist, but also has to equal to the function value at that point. The limit from the left, the limit from the right, and the function value at that point, all three have to exist and have to be the same number. And that's continuity at a point. Okay, I would like us to, I'm going to share my screen. Should I wait for a second?